Hello, children. Welcome to Right Tuition Classes. Children, in the earlier chapter, in the earlier part of this chapter, we saw that a force applied to a body pivoted at a point. Suppose any body, it's pivoted at a, suppose this is a body, children. A body is pivoted at one point, okay? P is the point at which it is pivoted. You apply a force at this body, okay? You apply a force F on this body. Now, this force, it doesn't move the body along a straight line. This body is not able to perform a translational motion because it is pivoted at a point. मतलब ये force के कारण ये सीधा आगे नहीं जाएगा. But क्या होगा बेटा? This body, it tends to move in, you can see here, this is what? Anti-clockwise direction. This body will rotate about an anti-clockwise direction. So what we saw, this body, on this body pivoted at a point. When a force is applied at a suitable point, it brings out a rotational motion in a body. We call it as a turning effect of the force. But my question now, do you think this force alone turns this body? Is this force alone is responsible for turning this body? Is this force F, what I marked here, is it alone responsible for turning the body? Now, if you're thinking yes, then you're wrong, beta. Why? There's one more force acting. Now, what is that force? I'll tell you. You have learned Newton's third law of motion. To every force of action, there's equal and opposite force of reaction. So what happens at this axis of rotation, equal and opposite force acts. This is nothing but this force is a force of reaction of the force you're exerting. This is a force of reaction. So both these forces, when you see better, they're equal in magnitude and they're opposite in direction. They're equal in magnitude, but they're opposite in direction. They're equal in magnitude and opposite in direction. And when you look at the line of action is parallel. The line of action is parallel. The line containing these forces, if you look at them, the line of action is parallel. The line of action is parallel. So such a pair of forces, which are equal, are equal in magnitude, opposite in direction, and the line of action are parallel, we call it as a couple force. So actually this couple force is responsible for the rotation of this body. So this force alone was not producing beta. There was a pair of forces. Like when you see, again, one example, the door of yours, okay? The door, open door, you want to close it. Okay, so you apply a force on that. Okay, you feel you're applying a single force to close it. Actually, you apply one force only, but at the hinges, axis of rotation, a reaction force acts in opposite direction. That direction of the reaction force and that force applied are opposite and they are parallel. Are you getting me here? So naturally, both of them together help you in closing the door. So a rotational motion is never brought about by a single force. It always happens due to a pair of forces. These forces are called couple force. What are they called? Couple force. Are you getting me here? Now listen, a couple force, I just told you like this. Now, if you want to bring out a greater turning effect, then these two forces should be applied explicitly on the body. मतलब दोनों फोर्स एक्चुअली एक्सर्ट होनी चाहिए, एक्शन रिएक्शन नहीं चलेगा, दोनों फोर्स एक्ट होगा तो greater, what you can say, rotation can be brought about, turning effect can be brought about. That is, we say both these forces should be exerted explicitly on a body to bring out a greater turning effect on a body. I hope people are understanding me here. So I'll give you some examples. Like if you see, suppose the car, the wheel of the car, okay? the wheel of the car has nuts. The nuts are opened by a special gadget. Those nuts are opened by a special gadget called wrench. I'll just show it to you. Wrench will be like this. Got it? So what happens is this part, okay, this part is the nut is fitted on this. The nut is fitted on this. And you apply equal forces on this. You apply a force in this direction, you apply a force in this direction. So can you see the opposite forces? And that will help you to turn that, what you can say, remove that nut from the wheel. Are you getting me here? So this we call it as a wrench. Got it? So you can see two equal and opposite forces. Equal and opposite behavior. Two equal and opposite forces. And the line of action are parallel. It will bring out a turning effect on the nut. Got it? So this nut can be tightened or loosened with the help of this wrench. In the same way, suppose you see the tap of yours, okay? You want to open the tap or close the tap. You cannot use single force. You use a pair of forces. Unknowingly use a pair of forces. Are you getting me here? Two forces you'll be using, which are equal in direction, equal in magnitude, opposite in direction, and it closes the tap. In the same way, with the help of a key, you try to open the lock. So unknowingly, on that key, you apply a pair of forces which are equal in magnitude, opposite in direction, line of action are parallel to each other. So the key gets opened up. Again, the steering of the car, you apply a couple force, I can say, equal and opposite forces. Okay, you apply. Okay, a bottle, that what you can see, the lid of the bottle has to be opened. It has to be opened. So you apply a couple force. I hope people understand me here. So basically, a pair of forces are responsible in bringing about a rotational motion on a body. This pair of forces are called couple force. Are you getting me here? So what is the definition of couple force, beta? Couple force, please see a couple force, okay? Couple force, two equal and opposite forces whose line of action are parallel. You don't have the same line of action. The line of action are parallel, are called a couple force, are called a couple force, are called a couple force. I hope everybody understood this couple force now. Now what I'm going to say, beta, I'm going to help you calculate the moment of couple. Okay, so we go ahead. Now we're going to learn a moment of couple. Okay, what is a formula for moment of couple? Okay, so let's see here, children. What is this moment of couple? Suppose I have a bar AB. I have a bar AB. I have a bar AB. Okay, AB is a bar. Got it? I'll write AB is a bar. Okay, it ends are A and B. It ends are A and B. Now, at both these ends, I apply two forces equal in magnitude, opposite in direction. I apply a force F on B, you can see in upward direction, got it? And I apply a force at point A, but in a downward direction. So when you look at the direction of the forces, got it? This direction of the forces are opposite, but the magnitude of the forces are same, FF. Got it? And this body is pivoted at some point O. It's pivoted at point O. Got it? It's pivoted at point O. So you can see here this pair of forces, got it? They're equal in magnitude, opposite in direction, and which bring out a rotational motion in the same direction, rotation in the same direction. we call it as a couple force, okay? So I'm interested in finding a moment of couple. So I'll say moment of force F, moment of force F, force F at end A is equal to F into OA. And you can see here, this is what you can say. This is anti-clockwise. What is this? Anti-clockwise. This is anti-clockwise. Are you getting me here? Anti-clockwise moment of force always positive. Likewise, moment of force F at end B will be equal to F into distance from the axis of rotation, OB. Again, this is anti-clockwise. Anti-clockwise. So naturally, both of them are anti-clockwise. Therefore, total moment of force, since both are anti-clockwise, I'm going to add total moment of force, okay, F is equal to F into OA plus F into OB. They cannot be opposite. So what will happen? F is common, OA plus OB. Now this F into, what is this? AB, OA plus OB. When you look at the figure beta, it gives you AB. So this total moment of force is called moment of couple now. Therefore, moment of couple is nothing but total moment of force, okay? Moment of couple is equal to F into AB. Now, F is, can I say either force? Got it? Therefore, can I say in words, moment of couple is equal to, F is either force beta, and this AB is nothing called length. This is length of the bar. It's nothing but arm of the couple. What do you call it? Arm of the couple. So remember, beta, one very important moment of formula. Moment of couple is either force, because they're equal in magnitude. कौन सा भी एक force लेने का, into arm of the couple. Arm of the couple is nothing but distance between the two forces. Arm of the couple is nothing but distance between the two forces. Got it? So now can I say moment of couple is equal to, can I define moment of couple? If you come across a question where moment of couple, this formula can be put in words. Moment of couple is defined as product of either force and the perpendicular distance between the two forces, got it? That is arm of the couple, okay? I hope you understood this better. This is called moment of couple, okay? So moment of couple, I just showed you, children. Now we go to the next part of this, okay? Now what is it? We'll see shortly. We start with another topic, equilibrium of bodies. Now, what do you mean by equilibrium of bodies? Okay. Now, see, suppose if a body is not fixed at any point, a ball is not fixed at any point. Somebody just kicks this ball. The ball tends to move ahead. Okay, the ball will move ahead. We say this ball is having a translational motion. Got it? A ball, okay? Somebody just pushes it, okay? And this body tends to move ahead, okay? So it tends to move in a straight line. So we call it as a translational motion. Likewise, suppose a body is pivoted at some point and you apply a force, not in any direction, okay? At a suitable point. I use the word suitable point. Then you see it brings out a rotational motion in the body. It brings out a turning effect. Now what I'm saying, beta, something totally different. the number of forces are acting on a body. Number of forces are acting on a body. Number of forces का मतलब क्या है? 2 force या 3 force act हो रहे हैं body के ऊपर. But still, got it? The body is at rest. It maintains a state of rest. Or if the body is in a state of translational motion, it maintains a translational motion. Or if a body is in a state of rotational motion, maintains that state of motion, rotational motion. And in such cases, we say the body is in equilibrium. We say the body is in equilibrium. So let's try to understand how this body is in equilibrium. I hope people understood me here. I repeat, suppose a body is capable of moving about, okay? You apply a force on that body, A. This body tends to move to a new position, B, along a straight line. Are you getting me here? This is in position A. It tends to move to the position B along a straight line. That means it produce a translational motion. Suppose a body is pivoted at a point, okay, and you apply a force at a suitable point. It tends to rotate the body, turns the body. We may say it brought out a turning effect in a body. Got it? Now what I'm saying, a number of forces are acting on a body. If a number of forces are acting on a body, and if the body is at rest, then it remains at rest. Or if it is in translational motion, then it remains in translational motion. Or if it is in rotational motion, then it remains in rotational motion. When it remains in rotational motion, then we say the body is in equilibrium. Body is in equilibrium. Okay. So how this is possible? So we are going to see how this is possible. Okay. We are going to see how this is possible. I hope people understood me what I wanted to say here. Got it? Like if a number of forces are acting on a body, and if the body is at rest, then it remains at rest. Or if it is in translational motion, then it remains in translational motion. Or if it is in rotational motion, then it remains in rotational motion. Then we say the body is in equilibrium. Okay. So I just made you understand now the definition. When a number of forces act on a body, and when a number of forces are acting on a body, and it produces no change in its state of rest or state of linear or rotational motion, then the body is said to be in equilibrium. So what is the definition? When a number of forces, same thing, what we have written earlier in big, I'm going to write in short. When a number of forces are acting on a body, when a number of forces are acting on a body, and number of forces are acting on the body, and it produces no change in its state of rest, or state of linear motion or rotational motion. Then the body is said to be in equilibrium. See, suppose a body is at rest. Got it? If a body is at rest, okay, so there are forces acting on the body. If you ask me where, how, I'll tell you. One is the weight of the body. Please have a look here. I'll just make you understand. Okay, see here. Suppose the body is at rest. Got it, children? Suppose this body is at rest. 1 minute, children. I'll just clear it. Suppose a body is at rest. I'll just draw it like this. This is a notebook. On the tabletop. I'll say this notebook is placed on the tabletop, or this object is placed on the tabletop. Then this weight of this object acts in a downward direction. Weight of the object. Weight is the gravitational force of attraction. Okay, so everybody has a weight. The weight always acts in a downward direction. But the table exerts an equal and opposite force of reaction on this body. Got it? Normal reaction force on this body. Equal and opposite force of reaction. The tabletop exerts an equal and opposite force of normal force of reaction on this body. Got it? So naturally, I can say this book is at rest. Okay, the way it was. So number of forces are acting, but still it tends to remain at rest. So I can say this book is in a state of equilibrium. This book is in a state of equilibrium. Are you getting it? It is in a state of equilibrium. In the same way, suppose there is a, I'll tell you, like the small children sitting on this. Got it? Suppose a child A who is very fat, okay? He sits at some distance from this pivot, okay? And as a small boy, he sits at the extreme end, okay? On this, got it? So now seesaw, on this seesaw. Boy A sits at A, is little sturdy boy, but it's at a smaller distance. This boy is a light body boy. He sits at a far off distance. And I see both of them. The weight force of this person is acting in a downward direction. The force of this person is also acting in a downward direction. So the direction, that is the weight acting in the same direction. Got it? But what is happening, beta? It is not turning. It is not bringing out. And you see, this wants to bring out anti-clockwise movement. Got it? This wants to bring out clockwise movement. Got it? You want to turn it like this. This wants to turn it like this. But it's not turning. It remains at rest. That means this body is in equilibrium. This body is in equilibrium. I told you the number of forces acting. And still the body is at rest. Or body is in a state of rotational motion, or, got it? If it is in a state of translational motion, we say, in spite of the forces acting, we say the body is in, what you can say, equilibrium. So I just give an example of equilibriums. But this equilibrium, I can, because I told you from the name, if it is in a state of rest, it remains at rest. If it is in a state of motion, it will remain in motion. So from here itself, I realize there are two types of equilibriums. Okay, there are two types of equilibriums. Okay, let's try to understand two types of equilibrium. Okay, types of equilibrium. There are two types of equilibrium, okay? One is, I'll just make you understand the types of equilibriums, okay? I'm coming to types of equilibriums, So one is, beta, try to understand, okay? Very, very simple. One is, I'll put it as static, word static, मतलब नहीं हिल रहा है. Static बोलो तो एक ही जगह में. Static equilibrium. Okay? And the other one is called dynamic. Oh, dynamic equilibrium. So what do you mean by, got it? So you should know, remember it, okay? What do you mean by static equilibrium? When a number of forces are acting on a body and still the body tends to maintain its state of rest, we say the body is having static equilibrium. Okay, so what is the static equilibrium, beta? When a number of forces are acting on a body, and the body tends to maintain its state of rest. Then the body is said to be in static equilibrium. So some examples I had shown you of equilibrium. They were nothing but examples of static equilibrium, okay? Like for physical balance, if you take, and on both the pans of the physical balance, you're putting better on both the, okay, this is both you're putting the same equal weights. So this will remain horizontal. Okay, it will not tilt in any direction. Equal weights have been put. That time we say it is in static equilibrium. Suppose a book is placed on a table. Okay, the weight of the book acts in a downward direction, but the table exerts an equal and opposite normal reaction force in upward direction. So the resultant force acting gets cancelled and this body remains at rest. Got it? Here also the forces get cancelled, it remains at rest. So we call this as static equilibrium. So when a number of forces are acting on a body and the body tends to maintain its state of rest, then the body is said to be in static equilibrium. Then what do you mean by dynamic equilibrium? Okay, when a number, please keep in your mind, when a number of forces are acting on a body, and the number of forces are acting on a body and the body maintains its state of translational motion or rotational motion. Then the body is said to be in dynamic equilibrium. I hope people understood me here. You're in dynamic equilibrium mode, number of forces are acting. And still the body tends to maintain its state of translational motion or rotational motion. Then the body is said to have what you can say dynamic equilibrium. Okay, like for example, here a raindrop. The weight of the raindrop acts okay. The weight of the raindrop acts in a downward direction. Got it? Downward direction. Okay. Whereas what happens? The upthrust acting on due to the air. Okay. There's an upthrust acting on this raindrop. Also the force of friction acting. So that forces, okay, the weight, please have a look here. The upthrust and friction are acting in upward direction. So these forces, they cancel each other. Weight is acting in a downward direction. Upthrust and friction are acting in upward direction. Both these forces cancel each other, and raindrop falls with a uniform, and raindrop falls with a uniform, drops to earth with a uniform velocity. With uniform velocity. So when you look at it, this is one example I gave you. But then there are other examples also. An aeroplane, it moves at a constant height. Okay, an aeroplane moves at a constant height when its upward lift is equal to weight of the aeroplane. Okay, the upward lift is equal to the weight of the aeroplane, then this aeroplane will move with a uniform speed in the forward direction. In the same way, a stone tied to the end of the string, when whirled, a stone tied in the end of the string, and when whirled in a circular path, got it, with a uniform speed, circular path with a uniform speed, okay, then the tension, please have a look here. The stone is said to be in dynamic equilibrium. Now, if you ask me how, one is a force of tension acting on the string, got it, away in the away direction, and the other one is the centrifugal force, which is centripetal force, which is acting towards the center, towards that, okay, inside, okay, the towards the hand, you can say. But now both these forces are acting, but still it tends to maintain its rotational motion. So we say it is in dynamic equilibrium. So I hope both this static equilibrium and dynamic equilibrium are clear to everybody, beta, so that I can go ahead. Okay, I hope everybody is understanding this. Okay, it's not difficult, children. It's pretty simple. You should only have presence of mind to understand it. Okay, now we go to the, so from here, the conditions needed for a body to be in equilibrium. So the first condition, I'll say, the resultant of all the forces should be zero, equal and opposite direction. So naturally both the forces cancel each other. The resultant force will be zero. So that is the condition. Resultant forces, the resultant force of the forces, okay, should be acting on the body should be zero. And secondly, the algebraic sum of the moments, the algebraic sum of the moments of all the forces acting on the body about the point of rotation should also be zero. So these are the conditions needed. Okay, so from here we realize one very important thing. The conditions needed, conditions needed for a body to be in equilibrium, either of the equilibrium. Okay, the first one, okay, the resultant of all the forces, the resultant of all the forces acting on a body should be zero, literally zero. And the second one is the algebraic sum of the moment of forces acting about a point, okay, is zero. That is, anti-clockwise movement should be equal to clockwise movement. So these are the conditions needed for a body to be in equilibrium. The result of all the forces acting on the body should be zero, and algebraic sum of the moment of forces acting at about a point, it should be zero. Got it? Then only I can say this body will be in equilibrium. Okay. Now, lastly, I go to the next part. What do you mean by principle of movements? So it's just like, okay, very simple. Once you learn, you cannot forget it. Okay. So what is this principle of movements? Okay. That is the sum total of, please have a look here. Then, okay, I'll explain. When a certain, like, or several forces, when a several forces are acting, several forces are acting on a body, pivoted at a point, at a point. When several forces are acting on a body pivoted at a point, okay, then they tend to either rotate it about an axis of rotation, got it? Or then they tend to rotate the body about the axis of passing through pivot. See, when several forces are acting on a body pivoted at a point, they tend to rotate the body about the axis passing through the point of pivot. Okay. Now, the resultant movement of force is obtained by adding anti-clockwise movement and the clockwise movement. Anti-clockwise movement and the clockwise movement. Are you getting me here? And if the sum of these movements is 0, then we say the body is in equilibrium, and anti-clockwise movement is equal to clockwise movement. Anti-clockwise movement is equal to clockwise movement. Are you getting me here? So remember this, we call it as a principle of movement. When several forces are acting on a body pivoted at a point, then they tend to rotate the body about the axis passing through the pivot. The resultant movement of force is obtained by adding anti-clockwise movement and clockwise movement. Now, if the sum of this movement is 0, when you go to add, then we say the body is in equilibrium and we say anti-clockwise movement equal clockwise movement. I hope people understood me here, children. Then next time we'll go ahead, okay? Anyhow, children, bye.